This is our video lesson for section 3.4, solving exponential equations by equating their bases. This is our first lesson in section 3.4. As you see in number 1, we have the base 5 raised to the 3x minus 6 equal to 125. What we have to notice is that 125 is a number we could write as a power of the base 5. So what I'm going to do here is rewrite the 125 as 5 cubed. When you do this, you can now see that we have both sides expressed as a power of the same base, which means the bases can cancel out and the exponents can be set equivalent. So 3x minus 6 would equal 3, and then we would solve that equation to find x. So 3x would equal 9, and of course x would equal 3, and that's our answer. Number 2, if we take a look at that example, our bases are 8 and 4. Now, the smaller base 4 cannot be written as a power that gives us 8, but both 8 and 4 can be expressed as powers of the base 2. As a result, I'm going to rewrite 8 as the base 2 cubed raised to the x plus 2, and the base 4 as 2 squared still raised to the x minus 3. You may forget that when you have a power to a power, you multiply those exponents. The good news is we have the same base 2 on both sides, so really what's implied is we have 3 times the quantity x plus 2 equal to 2 times the quantity x minus 3. Some people don't write that step, and I'm okay with that as long as you don't forget to distribute correctly and get 3x plus 6 on the left and 2x minus 6 on the right. So then to continue solving, if I get the x's on the same side, I'd subtract 2x from both sides as well as 6 from both sides. That's going to give me x equals negative 12. And of course, I can plug negative 12 back in. It's a little deceptive because if we plug in the original equation, we would get x or 8 raised to the negative 12 plus 2, which means the left side becomes 8 to the negative 10th. And on the right side, we'd get 4 raised to the negative 12 minus 3. That's 4 to the negative 15th. And you might think, well, the left side doesn't equal the right side. But that's because they're not expressed as a power of the same base. If I express the 8 as 2 cubed again, and the 4 as 2 squared again, you're going to see that in actuality, both sides would become 2 raised to the negative 30th. And so in actuality, both sides are equivalent. A calculator could have shown you that if you plugged in 8 to the negative 10th and 4 to the negative 15th, or maybe even better yet, when you check, it might be better to plug into the line where you equated the bases so that you could see that they really both become 2 to the negative 30th. All right, one more example, just 3 examples. Let me go down to example 3. I have 9 raised to the x plus 2 equals 27 raised to the negative x. Again, you want to think, is there a common base that I could use to express both sides as? And both 9 and 27, when I think of powers, could be written as a power of the base 3. So 9 is, of course, 3 squared, which would be raised to the x plus 2. And 27 could be written as 3 cubed raised to the negative x. So now I have equated the bases, both sides using the same base, And the power to a power says multiply those exponents. So I'd really have 2 times the quantity x plus 2 equals 3 times negative x. And that means you get 2x plus 4 equals negative 3x. And if you're comfortable going right to this line, again, that's fine. Just be careful that you do not make a careless mistake in distributing. So now I'm going to solve this resulting equation, and I am going to subtract 4 from both sides. So I would get negative 7. And at that point, oh, this is negative 3x. I was like, something's wrong here. All right, so we'll correct this. The right side becomes negative 3x. And so let's scrub this line. That was my mistake. Now I can see I would get 4 equals negative 5x. That looks more like it. And that means x would equal negative 4/5. And of course, I can check by plugging back in, but that might take a little work here, and we're going to go with that as our answer. All right. I hope that is helpful in how to do your assignment, which is in my Math Lab 3.4a. Have a great day.